Hello everyone and welcome to your all in mathematics class here. Yes, and today we are going to study this topic reflection symmetry. Okay, and here we will study the lines of symmetry for the different types of figures, such as here I have shown there are infinite lines of symmetry in a circle, and here in the rectangle it has two lines of symmetry, the lines joining the midpoints of opposite sides, and we will also see of the equilateral triangle also. Okay, so now let us start over here. We have to understand that what are reflection symmetry here, so that we can say that a figure is said to have be in symmetrical position. That means it is said to be symmetrical about a line L if it is identical on either side of the line L, means on the both sides it is similar only. Example, you can see that a line segment this AB is bisected through the line segment DC. So here the DC line segment, it is the line of symmetry which bisects the line AB into two identical parts here. Okay, so we can say that a line segment is symmetrical about its perpendicular bisectors. Now the angle has the line of symmetry which is the angle bisector, of the angle. That here this dotted line is the angle bisector, and this is only working as the line of symmetry for the given angle. Now next, a given angle having equal arms is symmetrical about the bisector of the angle. It is symmetrical about the bisector of the angle. Okay, now we have the rectangle. This figure is a rectangle and it has the line of symmetry which are the lines joining the midpoints of opposite sides. So it has only two lines of symmetry, that is L and M over here. So we can write that a rectangle has two lines of symmetry, each one of which is the line joining the midpoints of its opposite sides. Here the diagonals are not working as the line of symmetry. Now we have a square. A square has the four lines of symmetry. Okay, because the two diagonals also you will include which is joining the opposite vertices. Okay, so that we can say a square has four lines of symmetry, namely the diagonals and the lines joining the midpoints of opposite sides. They are the line of symmetry here. And now the rhombus. Rhombus, we have to see that square is also a type of rhombus only, but in the rhombus, in other rhombus we can say the angle is at the corner 90 degree, it is not conform. Okay, so it has only two lines of symmetry, namely the two diagonals, the lines joining the midpoints of opposite sides, that is not included here. So we will say that the rhombus is symmetrical about each one of its diagonals. So it has two lines of symmetry about which this rhombus is divided or bisected in two identical parts. Okay, now the circle. So each diagonal, each diameter is working as the line of symmetry here, and as we know that it has infinite lines of symmetry because it has infinite diameters. So our circle is symmetrical about each one of its diameter. So a circle has infinite lines of symmetry because we can draw the infinite diameters in the circle. So a circle has infinite lines of symmetry. Now here we are seeing an equilateral triangle. In the equilateral triangle, what is there, that the angle bisectors of each and every interior angles are the line of symmetry, and each angle of the equilateral triangle is equal to 60 degree. So it is bisected by a line which bisects the interior angle into two parts, that means 30 degree and 30 degree, and these lines are only the line of symmetry. Okay, so we can say that like in equilateral triangle, a triangle, it is an equilateral triangle is symmetrical about each one of the bisectors of its interior angles. Interior angle bisectors, these three lines of symmetry it has. So we can say the equilateral triangle has three lines of symmetry here. Now you can solve exercise 18a, question number 1 to 9 there, and you may draw the diagrams of the figures what I have explained with their lines of symmetry here. also write the number of line of symmetry in the figures. Okay, now revise this all concepts nicely, watch this video nicely and try to understand all. So thank you all of you and have a nice day.